All right, Chem 11 students. Welcome to another problem solving session. This one is for the limiting reagent and maximum yield worksheet that is placed on your D2L page for the class. To do the problems today, I'll need a periodic table, Mendeleev edition, and the Calculator-O-Matic 3000 solar powered edition. So when an asteroid strikes the Earth and knocks out all the power, you will still be able to do your chemistry. Anyway, I'm going to remove these things, get them out of the way. Need that periodic table for the molar masses, right? So we'll do that. Now, I'm not going to do all the problems on this sheet. There were 16 of them. I'm going to do 6. I'm going to try to get through them rather quickly because I know some of the steps you're already used to doing. So we'll do number 1A and 2A. Number 1 and 2 went together on the sheet. There's an A part and a B part. They're solved the same way, so I'll just do the number 1 part of it. So 1A. All right, number 1A. And the problem is that we have aluminum and chlorine gas combining together to get aluminum chloride. And it says that I have 3.6 moles of aluminum, 5.3 moles of the chlorine, and it wants to know, 1, what is my limiting reagent? That was the A part of it. What's my limiting reagent? And the B part of it was, what's my maximum yield of the product? So I'll put a little B here, and A was the limiting reagent, which we will figure out. All right? So, I'll do my answer in blue here. So they told you aluminum, chlorine gas, and aluminum chloride. The first thing I need is that recipe. I need to balance this chemical equation. So the aluminums are okay, but the chlorines are not. I've got a 3 and a 2. Whenever we have a 2 and a 3, we make them into 6. So this ends up balancing the whole thing. All right? All right, so what I'm going to do, I always take this one that is on the left. It's the way I do it. It's not, it's not the be all and end all. You can take this one over here. But I'm going to multiply it by the mole ratio, which the head of the arrow is at 3, over the heel of the arrow, which is at 2, head over heels for my mole ratio. And then I end up with 5.4 moles. So now remember, all right, we've got 2 values here, this one and this one. This is what I got, right? So I underline them. I know I have that. I know I have that. That's what I got. That's what I'm working with in my lab. This down here is what I need, right? I need 5.4. Well, how much do I got? 5.3. So to burn off all 3.6 moles of aluminum, because I have 3.6 moles of aluminum, I need 5.4 moles of chlorine gas. I only have 5.3. So I'm not going to be able to burn off all the aluminum. I will run out of chlorine. I need this, but I only have this. So chlorine is my limiting reagent. And I always write it over the top of it. And that means this is my excess reagent. So my limiting reagent is the chlorine gas. All right? And so for all further calculations, I'll know any product that I have to find, and I will have to do that in B, I'm using what I got of my limiting reagent. So part B, the maximum yield of this, all right? I'm going to use this value. Now, a common mistake, I see it every so often, someone will use the 5.4. Oh, chlorine, there's 5.4 moles. Remember, this is what you needed. This is what you actually are working with. This is what I got. So I have to bring over the 5.4. Oh, sorry, the 5.3. Gee, I just said that. 5.3 moles not the 5.4. This is what I actually got. And that's why I underlined them, so that I know they stand out. This is what I'm working with. This isn't. So multiply that by the mole ratio, and the mole ratio for this one is going to be the head of the arrows at the 2, the heel of the arrows at a 3 for my equation. And that ends up being 3.53 moles, depending on how you round it. Maximum yield is in mass, so I got to multiply by the molar mass. I'll get out my periodic table, and I'll take a look. I'll add up. Now remember, you're only adding up Al and 3 Cls. This 2 is already used up here, so it's not. I'm not adding 2 Als and 6 Cls to get this number. The 2 is gone. I'm using just the formula. Just the formula. When I add those components together, I get 133.33 grams per mole. I multiply those. The moles cancel. I'm left with grams, and it's going to be 470.655 grams. All right? So 1A was this side of it. 2A was this side of it. All right? Pause the video now, get that down, or check your work, and I will set up for our next question. I'm going to do number 3. Messed up my title a bit here. I'll see if I can fix that. All right. Number 3. Number 3 had P2O5 plus water to form phosphoric acid. And when you balance that off, there's a 2 here, a 6 here, and a 4 here. So there's my recipe, my balance equation. First thing I need right there. Now, what did they give me? They told me that for this I had 0.48 moles, and for this I had 1.52 moles. And the first thing I have to do is find my limiting reagent. I got to find out which of these, right, I'm going to have to do. I know B was asking me the maximum yield of that, and C was actually asking me how much of my excess reagent was left unused, right? If you remember, my limiting reagent gets entirely used up first, but then there's some of that excess reagent left over. So that was what C was asking about. We'll do C when we figure out, well, what is my limiting reagent? We'll figure that out. So let's do this. We were given these molar amounts. I always take this one, bring it over. So take my 0.48 moles, bring it over, multiply it by the mole ratio, which is 6/2. And that ends up being 1.44 moles. Now, let's get it in our heads the way we have to think about this stuff. All right? This is what I got. All right? This is what I got. I got that and that. I'm underlining it right now. That's what I can actually use over here. I'm using this number or this number, not this one. I'm using one of these two to figure this out. This is what I need, all right, to react all of that. So let's take a look at this. I got 0.48 moles of the P2O5. To react all of that, I need 1.44 moles of water. Well, I got way more than 1.44. I have 1.52. So this is my excess reactant, and the limiting reactant or reagent is the P2O5. All right, so P2O5 is my limiting reagent. All right, so now what I'm going to do is I'm going to bring this over. So I'm going to draw my arrow, and I'll show you a little shortcut. I just go like this. I draw my arrow like that. I'm pretending I'm drawing it from there, and I still bring over the 0.48 moles, what I have of my limiting. And I multiply it by the mole ratio, 4/2. And that ends up being 0.96 moles of the phosphoric acid, but maximum yields are in grams, so I'm going to have to multiply that by its molar mass. So I get my periodic table, and I add just the formula, 3 H's, a P, and 4 O's, and that ends up being 98 right on the button grams per mole. I multiply that, and it's 94.08 grams because the moles will cancel out. All right, grams of H3PO4. And that is my answer to B. All right, so now C wanted to know how much of my excess reagent, which I now know is the water, how much of my excess reagent do I have left? So let's figure that out. I'm going to move this. Now, what I'm going to do is I'm going to look at my water. This is how much I started with, and this is how much I needed to react all of this. So to get rid of all my limiting reagent, because we figured out that this is the limiting reagent, to get rid of it all, I need 1.44 moles. I had 1.52 moles. So what I'm going to do is, for C, I'm going to take 1.52 moles, right? That's how much I started the lab with. I'm going to subtract how much you needed to run and burn off all of that stuff, right? I needed 1.44 moles to burn off all of this limiting reagent, and I know this one disappears or gets consumed first, so I needed 1.44 moles to do that. Start with this, I burn this off. When I subtract those, I'll get how much is left unreacted, and that's 0.08 moles. And then what I'm going to do, because it said what mass of water is left, or what mass of the excess reagent, which we know is water, is left over, I multiply that by its molar mass, so 2 H's and an O, 18.02. Probably remember that for water now. And I end up with 1.44 grams of water. Now, on the answer key I posted, I did make a mistake, and I think I did the molar mass of P2O4. So this is the real answer. All right, this is the real answer for C. I used, right here, I made a mistake with this. I used the molar mass of that material rather than water. So this number was different, which meant this number was different. All right, a silly mistake, but it followed me through my work. Anyway, there's number 3 done. The limiting reagent was the P2O5. I used the moles that I had of the limiting reagent to figure out the maximum yield of the phosphoric acid. And then I used how much I had of the water, subtracted how much got used up in the reaction, found out how much water was left over, and converted that into mass, and it's 1.44 grams. All right, pause this, take a look at it, get it down. I'm going to set up our next problem. All right, number 3 we just did. I am going to do number 7. I can't do all 16. YouTube will kick me off. It'll be like a 3-hour video. Anyway, number 7. The first thing we wanted was an equation between beryllium chloride and aluminum sulfate. And they were involved in a double displacement reaction. So they just switched partners. They switched the front part. So Be is now at the SO4, and aluminum is now at the Cl3. All right. And it said I had 100 grams of this and 350 grams of that. And it wanted the masses of both of these. I'm going to have to spread these apart a bit, I think. AlCl3. All right. So A was the balanced equation. Names and formulas, still got to know them. Right? So they gave you the names in the question. These are the proper formulas. And then I have to balance it. And it balances by putting a 3 here, a 3 here, and a 2 here. Now everything is neatly balanced. The first step, find that limiting reagent. I've got this and this. I've got to find the limiting reagent. I'm going to turn them both into moles. I will do my answer in green. So this one I'm going to divide by the grams per mole for BeCl2, and that ends up being 79.91 grams per mole. All right. When I divide this out, I get 1.25 moles. Right? Going to take the molar mass of this. When I add up those components using my periodic table and my calculator, I get a molar mass of 342.17 grams per mole. When I divide that out, I end up with 1.02 moles of the aluminum sulfate. Now I'm going to, I always take that first one and I'm going to bring it over and say, look, if I burn off all 1.25 moles, and that's what I have of this because I have 100 grams, that's what it is. If I burn off all the beryllium chloride, how much of the aluminum sulfate will I need? So I multiply it by the mole ratio. The mole ratio I get from the coefficients. There isn't one here, but we know there's a 1 there. We couldn't see it. So 1 over 3. And that ends up being 0.42 moles. Now again, in your head, what steps do we got to do? These two numbers right here, that is what I got. All right? I got this, I got that. This down here, this is what I need. All right, so to burn off all 1.25 moles of beryllium chloride, I need 0.42 moles. Oh, I got way more than that. I have 1.02 moles. I only need 0.4. I have over 1. So that means this is my excess reagent, and the beryllium chloride is my limiting reagent. I didn't leave myself a whole lot of room up here, so I put some room underneath. So my limiting reagent is the beryllium chloride. So I'm going to put a box around that. That is what I'm using to figure out products over here. Now this question wants the masses for both of them. All right. So what I'm going to do is I'm going to bring over my 1.25. I'll make it a different color here. So bring over 1.25 moles. And I multiply it by the mole ratio. In this case, it's 3 over 3, which equals 1.25 moles of the beryllium sulfate. I then multiply that by grams per mole, the molar mass of beryllium sulfate. Add up the components on the periodic table, it's 105.08. Multiply that, and I get 1.25 times that. $106. I think I made a mistake here. I'm going to double check that. So I'm going to use my calculator. That just looked odd to me. Bear with me here. I think this number's wrong, the one I wrote down here. I think I missed the button on the calculator. 1.25 times 105.08 equals, see, I did, look at that. It's 131.35. I caught myself. 131.35. So I'll have to fix that for number 7. Fix that on your, that's grams because the moles canceled. So, good catch. This is my maximum yield of this up here. All right. On your answer key that I posted, it's 106.33. It's actually this. All right. So make that, fix that in your thing. Bringing it over again. Again, I don't need the arrow to be here. I can just bring it over like this. You can see the arrow short, but I understand that I'm starting it from my limiting reagent, which is here. My mole ratio in this case is going to be 2/3, and that will equal 0.83 moles. And then I'll multiply that by its molar mass. That will cancel out my moles. The molar mass of the AlCl3 is 133.33. We used that in an earlier problem. And I get 110.66 grams of the aluminum chloride. All right, so this one is correct on your answer sheet. This one I put in there wrong. This is the correct answer. All right, so that's A, that's B, this is C. I now have to do D, but to do D, I have to erase some of this. I'm running out of space, as you can see. So pause the video, get this stuff down. I'm going to erase this stuff over here so I can use my data from here. All right, so that was already figured out. Now, to figure out what gets used up. So this is D right here. I'll do it in red, D. So I got 1.02 moles of the excess, because this is my excess reagent. In the reaction, I'm going to burn off 0.42 moles, gets used up. All right, this is what I got. That is what is used. And this is what I'll have left over. And when I subtract those two numbers, I end up with 0.6 moles unreacted or left over. All right. Now I'm going to multiply that by the molar mass. Now it's the molar mass of this, right? Remember, this work is from my excess reagent. So I'm using this molar mass right here. 342.17 grams per mole. And it ends up being 205.3 grams. The moles cancel out. And that is my answer. All right. So we started with 350 grams, but a lot of it wasn't used, right? If this costed a lot of money, you just wasted a lot of money, because now I can't put this back in the container. I only use 150 grams, 200 of them are still sitting here, right? So that's where stoichiometry can come in very handy. If you have something that's very expensive, you know exactly, you can calculate exactly how much of that you'll need. So you're not wasting it and getting fired. All right? So here's D done. This is how much is unreacted or left over. All right? The next one I'm going to do is number 12. So I'll erase this. Pause the video now if you need to. I'm going to erase it. We'll do number 12. Hopefully we're hitting on all aspects here. That last one hit on pretty much everything. All right. Number 12. Number 12 was a question that involved, part A was, come up with the equation. So zinc got dropped into some hydrochloric acid and formed zinc chloride and hydrogen gas. It's a single displacement, right? And so that was part A, was this, and then we had to balance it off, and to balance that off, I can see I got 2 of each of these things here, so I'm going to put a 2 there, and now we are balanced off. Everything is A-OK right now, as far as A goes, the balance equation. B says if I have 70 grams of this and 50 grams of this, what is my limiting reagent? So again, I can't compare things in an equation with mass. I got to turn them both into moles. So I'm going to divide zinc by its molar mass, which is pretty easy on the periodic table. It's 65.39. When I divide that out, I get 1.07 moles of zinc. I'm going to divide this by its molar mass, the hydrochloric acid. And when I do that, I get 36.46 grams per mole. The grams will cancel out when I divide, and I'll be left with moles. And in this case, I end up with 1.37 moles. And now I'm going to say, if I use up all of this zinc, if I use up all 70 grams or 1.07 moles of zinc, how much hydrochloric acid will I need? All right. So I multiply it by the mole ratio. In this case, it's 2 over 1. 2, and I know there's a 1 here that I can't see. So I'm going to end up doubling this, and it ends up being 2.144 moles. And again, think about it like this. This is what I got. I've got this, and I've got that. That's what I actually have. The 50 grams and the 70 grams, that's what they are in moles. This is what I need. Right? That. So if I look at it, to burn off all of this, I need 2 moles. I only have 1.37 moles. I do not have enough to burn off all the zinc. Therefore, the HCl is my limiting reagent, and the zinc is my excess reagent. All right, let me go over that again. This is my zinc. To burn all the zinc off, I need 2.14 moles of the acid. I only have 1.37 moles of the acid. Therefore, I don't have enough of this HCl. It's going to run out. I won't be able to burn off all the zinc. Some zinc will be left unreacted. All right? So, I think the next part of this asks how much of the excess reagent will be left over. Right? I don't think this one asks for a particular product. So, how much of the excess reagent will be left over? So, here's my excess reagent. Well, I know what I have, but I don't know how much I used up. So what I'm going to do is, I'm going to have to take this and bring it over here. Now, I don't have room, so I'm going to erase this. So pause the video if you need to. I figured out what my limiting and excess was. Again, this is the beauty of turning them both into moles. I can work it either way. So now I'm going to bring this over to here. 1.37 moles times my mole ratio, which is 1. The head of the arrow is at the 1. The heel is at 2. And that ends up being 0.685 moles. And that's how much moles I need of zinc. All right? So let's take a look. I figured out earlier that this is the one I'm going to use up entirely. I'm going to run out of this. When I use up all of this, all 1.37 moles, I'll need 0.685 moles of zinc. I got 1.07 moles of zinc. So now I'm going to take this number, what I started with, how much I have, and subtract what I needed. So I'll do that over here. So I'm going to do got minus needed, or used up. And I have 1.07 moles of the zinc. I'm going to subtract the 0.685 moles that will be used up. And this will be the amount that is left over, which is 0.385 moles. And then I have to get the mass of it. So I'm going to multiply. Remember, we're working with zinc, so zinc is right off the periodic table, 65.39 grams per mole. Multiply that out, and I end up with 25.175 grams. The moles cancel. And that's of zinc. And that's unreacted. So we put in 70, but 25 of those grams didn't get used up. Again, this is the beauty of stoichiometry. If you do it right, you don't end up wasting, valuable chemicals. All right, our last one, number 16. Pause the video right now if you need to, and I'll set up number 16. All right. Number 16. Says if I have calcium hydroxide plus aluminum fluoride, I'll end up with CaF2 and AlOH3. Formulas have to be automatic for you guys by now. Always, always, always going to be using our formulas. Of course, now I have to balance this. So to balance it, 3 here, put a 2 there. I'm going to put a 2 here and a 3 here. All right. Balancing hopefully is automatic for you guys by this point as well. Now it said, hey, we got 100 grams of each of these. It wants to know what is my limiting reagent and how much of that excess reagent is going to be left over. So it's just like the last question, number 16, number 12, and 16 were very similar. What I'll do also, I'll find, you can see online, you know, if I didn't know my limiting reagent here, I can find the mass of either of these, but we've done that sort of stuff. So we'll identify our limiting reagent here, and then we'll find how much of that excess reagent is left over. It's an interesting addition, you know, to these problems. I'll do my solution in a different color, so I'll do it in green. So I'm going to divide by the molar mass for the calcium hydroxide. Again, I just do this. I don't use the 3. And when I divide that out, I end up with 1.35 moles. Do the same thing here for my aluminum fluoride. Again, I'm just doing the Al and 3Fs. I don't use the 2. I'll use that later. So when I add up an Al and 3Fs, I get 83.98 grams per mole using my periodic table values. When I divide that out, I get 1.19 moles of that. I always take this one and bring it over, so I'll keep doing that. 1.35 moles times my mole ratio, which in this case is 2/3. Head of the arrow is at 2, the heel of the arrow is at 3, head over heels. And when I do that, I end up with 0.90 moles. So these values right here and right here, that is what I got. This is what I need. So let's take a look. To burn off all of the calcium hydroxide, all 1.35 moles, I need 0.9 moles of this. The aluminum fluoride, I need 0.9 moles. I have more than 0.9. So when all this is gone, I'll need 0.9 of this. I got way more. So this is my excess reagent, and the calcium hydroxide is my limiting reagent. The question asked, how much of this excess reagent, the aluminum fluoride, is left unreacted? Well, this is great, because we look at these two values. I have how much I started with, and I have how much got burned off, because I know we use up all of this, so when that is all used up, I'll need this much of the aluminum fluoride. So I have how much is burned up and how much I started with. So I'm going to subtract these two numbers. So take what you got, subtract what you used or needed to run the lab, and you'll get the leftover amount. So I got 1.19 moles. I'm going to subtract 1.35 moles. And how much was left over? When I subtract those two numbers, it's 0.29 moles that was left over. I'll take that 0.29 moles of the aluminum fluoride, and I'll multiply by its molar mass, which, again, I already figured out right here, 83.98. The moles will cancel out. I'll be left with grams, and it will be 24.35 grams. So this is the mass of AlF3 that was unreacted. All right. Anyway, that's a whole bunch of the problems done for you. Hopefully, it was nice and clear and it made sense. If there's any questions, comments, or concerns, by all means, comment in the comment section of this YouTube video, or if you're one of my students, reach out to me through Edsby. All right. Have a great day. Hope it was clear. Ask questions if you're not sure. Talk to you soon. Bye-bye.